All right, I'm going to show you how to um, take data from a PDF, a journal article, and put it into Microsoft Excel. I've chosen this particular article because it's got a lot of data and we're going to be using it. What you can see is once you have this article, it's got all of this data right here where ND is, so we've got X1, which is the mole fraction, it tells you right here. We've got a bunch of other stuff, including density, viscosity, and refractive index. For pentane, which is one, component number one, which means we are looking at the mole fraction of pentane in this column here. We've got more mole fractions for one or X1s here and more refractive indices. So what we're going to do is we're going to cut and paste this data into an Excel document so that we can access it. I forgot the titles there, but otherwise I'm just going to keep going down. It's going to let me highlight all this data. I'm going to get all the way to the bottom. Oh, there we go. And it looks like the data stops right there. So now I have all my data highlighted, and I'm going to hit Command C. Um, and I could also, in Acrobat, go to Edit, Copy. And now I'm going to come over here, and I like to go down, let's say to 6 or 7 rows, and I'm going to start with row 8, and I'm going to just hit Command V or on a Mac or paste. And there's all our data. It's not in a usable form yet though. So from here, what we're going to do, all of this data is in column number 1, and all of this data is already highlighted. You can see it goes all the way down there. Now the trick here, which I love, is if you go to the data column and do text to columns, it will ask you how you want to do this. We want to do delimited, and it means, and these are the delimiters, and our delimiters in this file are spaces, the way it's copied it. So as long as space is highlighted here, I think I've been doing space. So you take away the space, you get no columns here. Check that, and it also says treat consecutive delimiters or consecutive spaces for us as one. That's good too. And now I'm just going to click finish. And it has broken up all of our data into columns already. I did miss my first column heading here, which is pentane 1 and hexane 2. I can see I've got pentane 1 and heptane 2 for my next set of data. So I'm just going to write pentane 1 and hexane 2. I know it's a little different there, but at least I'm keeping track of my data. Now I want to do several things, um, and I'll make my data bigger, hopefully, so you can see it. It's a little too big. Oh, I can make this wider. There we go. So now what I've got here is I've got some X1s, and actually I'm going to put X pentane so that I know that's my X of my mole fraction X. So hold on. X pentane. That close enough. That's my mole fraction of pentane. I got my other stuff, and then here's my refractive index. So I'm going to use ND, and I've got more of them over here, and it goes 0, 0.1, 0.2-ish, all the way up to 0.5. So I know my data is going to be the 0.6 to 1 column here. I have 5 more pieces of data, and my 1.36 numbers, those are going to be my refractive indices. That's what I want to get in one column over here. So I'm going to insert 1, 2, 3, 4, 5, 6. And here I have an insert. So, and as soon as I hit insert, it inserts rows. If your spreadsheet is not that wide, you might end up going to something called cells and then insert. It'll still do it. And of course, it might be different on your version of Excel. And what I would recommend, by the way, is that you insert 6 or 7 rows for all of them at once. If so, as much data as you have, and there's quite a bit of data here. And then what I'm going to do is I know here are my index, or sorry, my mole fractions. And I'm just going to copy and paste over to my refractive indices. So I'm going to copy. Did I copy? Yeah, I could copy, I could cut. I'm not going to need it again, but and now I'm going to paste. And when I do that, I now have all of my mole fractions here, I have all of my refractive indices here, and I can go ahead. There's a number of ways to do this, but I like to click and highlight all my data, insert it into a graph, and then if you click on each individual data set, you can cut them. And just leave your refractive index on the y-axis in the blue column, and your mole fractions in the purple column, and then you have a graph of that. You can label that. That's going to be ND versus X pentane uh, with hexane. And sometimes you do that in the title, since there's only going to be one in this right now. And sometimes you use the legend. Either one's fine. And I like to go ahead and just turn this into a mole fraction that only maxes out at 1. And what you can see is the bend in this is slightly positive, slightly higher refractive index values than ideal. And that's a good thing to do. Uh, Turns out we're not going to need that. Well, you might need that, but it's going to get busy here. So I guess what I'll do is I'll push it over here, slide it to the side and get it out of my way. All right, now we're going to do some data manipulation to do the analysis that we need for the poster. And this is for many of the posters in the spring 25 semester. So this is going to be DND, which to me is Dungeons and Dragons. But for us, it's going to be DND. I'm going to change my font to a symbol, which means it's going to be delta ND. That's going to be the change in refractive index. And there's a formula for this. And the change in refractive index from the ideal value. So this is going to be from the ideal value, and we can talk more about that. But DND is going to be, the formula is going to be equals. It's going to be whatever the experimental value is. That's going to be minus. And for this particular case, you can see that at 0 mole fraction, it's going to have a higher refractive index. And at 1 mole fraction, it's going to have a lower. So, and it's always the difference here, 1.3732 minus the other one, 1.3547. And that's going to be times. And when it's higher for 0 mole fraction, you actually have to do 1 minus the mole fraction. If it at 0 mole fraction, the refractive index was higher, you don't have to do the 1 minus part. You would just do mole fraction. So it would just say A8 there instead of 1 minus A8. And plus the lower mole fraction. And, oh, I did my spacing wrong. I need 2 open parentheses there and a closed parenthesis there. You can see that's going to make all the difference because now it's 0. And here is the equation. And I'm putting in the value for the higher one. Well, anyway, I just pointed at the screen, not that you could see that. That's the formula. And now what I'm going to do, so what does it do? It takes the experimental value, which is an E8. It subtracts off the difference between the pure components times the mole fraction and adds the lower one. And that's effectively, so it's E8 minus the line of ideality. So the rest of it is how to subtract the line of ideality. And then you're going to go ahead and cut and paste that down. You can, so I don't know if you saw that, but you can go over this lower portion here. You can click and drag. That copies and pastes it. I'll undo that. You can Command C or Control C, depending upon what type of computer you're on, and then Command or Control V, and it pastes it in there. That works as well. What you want to make sure, though, is that your values on both ends are 0. That's a good hint that your equation is working correctly. And that the values are small, and you can go ahead and click on any of these and see how it's referencing the cells in its row. And these are reasonable delta ND values, change in refractive index values. And now we're doing what I hope will turn out to be our contribution here is we're going to actually do dnd divided by dnd here. And I'll convert some of these d's into symbol deltas so that we've got, so delta ND, which is going to be the column right here, minus, or divided by delta ND pure. And that means, so that what we've found is that it's not just delta ND, but it's delta ND divided by the change in refractive index between the pure components. And to show you what that looks like, so delta ND is just the value next to it. And we're going to divide it by, there's an easy way to do this. Come over here and double click and drag to highlight this difference here. And then hit return so you don't screw up that formula. And then come over here and it equals delta ND divided by, but, oh, it didn't like that. So let's try that again. So, all right, so copy equals, let's see, maybe this doesn't work, divided by, yeah, there it does. Oh, and I didn't remember my parentheses. You need parentheses for order of operations. You wanted to do the subtraction first, or sorry, this subtraction before you do the division. And you get 0 because it was 0 in the numerator. Then when you double click here, that's well, you can click and drag. If you watch your cursor turn into this from the bigger plus to the smaller, thinner plus, you can double click on it. Up, it only went down to there. So I still have to click and drag. And you get these nice numbers here. These numbers are bigger because you're the difference in, let's see, so that's the difference in the refractive indices of the pure components. And it's 0.018. So that's a small number, less than 1. So when you divide these numbers by this, and it's the same all the way through, you get a bigger number. And these are the numbers that we're interested in. And now you're going to graph these numbers. And again, there's many ways to do this. I'm going to go ahead and click and drag over all of it. I'm going to insert all of that, right? You can see I've inserted all of that. And then I'm going to take away by hitting the delete button. Hit the delete button on, oh, I don't want, yeah, I do want to get rid of that. The ND. This is the 0.7, which is the density. This is the 0.3, which is the viscosity, I think. And then you've got two sets of data. The really, really small numbers, the delta NDs, you can get rid of. And we've got this data here. And again, I like my mole fraction to be physical, so I want it to just go to 1. And there's lots of things that we'll talk about to do with this data. But right now, a couple things we're going to do is we're going to label the vertical axis. And I'm just going to, I think actually the way to do this is just with it, single clicked copy. See if it does this. And then paste. Yep. Oh, it took away my symbols. Let's see if I can put them back by highlighting it. Yep. I don't think I figured out how to do subscripts here yet. There we go. So now it at least matches that. And now my x-axis, I'll have a title. So chart design, axis title horizontal is going to be small fraction pentane for this graph. And I've got my series here. And let's mess with that in a minute. Keep double, triple clicking until I get this. And this is going to be delta ND, changing my fonts, the symbol SYM, changing my font to symbol for that part. Let's make that go away by clicking on it. Versus X pentane for binary solutions. And I'm not going to say hexane there yet. I am going to go ahead and click on the edge of this and then make the size smaller to 10 points. And let's see, I think that'll stay there, my legend. I am going to need my legend, and I'm going to make it as big as possible, this graph. Drag my graph down a little bit. Drag my graph up a little bit. Give me some space, and if you know me, you know that I will eventually get rid of those grid lines. But look at this data. This data's a little bumpy, a little chop in the data, as we might say. But that's okay. We're done. Guess what? Now we do it again. And okay, so we did X pentane and hexane all the way over. I'll do it one more time for pentane and heptane. It's overrunning my data here, so I'll make this a little smaller for now. Just to repeat what we did, I'm now going to put in my columns. 1, 2, 3, 4, 5, 6, 7. I like to just use 7 because then I go pentane down to the next pentane. Insert my, ooh, don't do that. Let's try that. So copy, it inserted what I last copied into all those. So I just copied a blank cell. Now when I insert, it'll insert them blank. Go a little bit faster now. So let's see. So here's my mole fractions. Again, you can tell, and you can label them too, if that helps. But they're going to go from about 0.6 to 1. And then my refractive indices here. Now I've got all of my refractive indices. Oh, no, I don't. They go there. Good. And I just can Command or Control Z to undo it, and then Command V to paste again. Now, all right. So now these two are the same. Oh, all three of these are the same. Copy, paste. I know these are not them yet, but, and now I'm going to copy this formula down here, and it's certainly not the correct formula. All right, now let's see what we do here. And I guess I can make this, oh, I can't. Let's make it even a little bigger. All right, so now I can see that the 1.3732, that's supposed to be this number right here. The 1.3547, that's the same because we're still dealing with pentane and a mole fraction of 1 pentane. This is still the same. The 1.3547 is still the same. We're still going from 0 to 1, and the refractive index here is higher at 0. So all right, So everything about this formula is the same as it was, except now I'm going to hit enter. I'm going to copy this, Command C. I'm going to double click that, and I'm going to double click that. I'm going to paste, and it pastes in the exact number we want. Many ways to do that. That's the way I've found so far. And it should go to 0. And when I click and drag down, it should be 0 at the other end. That's an indication that things are working. For this, my delta ND is going to be this column here divided by delta ND pure. Delta ND pure, I'm going to try and grab these parentheses this time, is this part. So I'm going to copy that, hit return so I don't screw that formula up, which believe me, I've done many times. And now here I'm going to hit equals. I want to hit the delta ND box next to it. I'm going to hit divide by, and I'm going to hit paste. And it pasted in with my parentheses this time, and I got 0. Proof is in the pudding though, so as we click and drag down, we should have numbers that are bigger than the delta ND numbers. They should be comparable to the numbers right above it, so you can see they all have 1, 0. And then the second decimal place is a number. So that's a good indication that things are okay. Um, and this is for pentane and heptane. So the last thing I'd like to do, I think in this video, to get you started with this process, is show you how to add another set of data to this graph I've already got. And I'm going to do 2 fingers on mine, or I guess I could do, yeah, whatever pulls up the menu, whatever you have to click on your mouse pad or trackpad in my case, and you're going to choose select data. I don't know how you do that otherwise, but, and then up comes this select data source. And I know that the data I've already got there is hexane, and in fact, it's N-hexane. So I'm going to put N-hexane in there, and then it's already got the data. I don't understand, well, I sort of understand that, but, and now when I hit tab, it's going to call that N-hexane over here. And what I'd like to do is I'd like to add another data set. So I'm going to hit the plus sign. I know that this data set is N-heptane. So I typed in N-heptane there. My X values I know are my mole fraction. So I'm just clicking and dragging here. And their positions shows up in the X values list. Then I'm hitting tab to go from one to another of these boxes. And then I want to graph delta ND over delta ND pure. So I'm going to click and drag. It puts it right in there. And then I'm going to click OK. And when I do, I now have a second data set. And if I want to see these, I can click over that. It says series N heptane 0.5999, and it tells me the value 0.0917. Graphically, that makes sense. It's right above the 0.09 line. And that is a start. Oh, and it's got my N-hexane and my N-heptane down here. Further, I guess I can do it since I'm here and I'm making this video, and as if this video isn't long enough, I will go ahead and do, let's see, chart design. I will grid lines, get rid of grid lines, get rid of grid lines. It'll uncheck it. I can see now that I don't have a box around it, so I'm going to click the box to get this highlighted and then double click it. And my border, I always like my border to be black. Now I click off it and I've got a nice black border. I do not have black axes, so I'm going to single click on my axis. I'm going to have a line that is also black and a line that is also black for the x-axis. Oop, it didn't do it. Got to get that there. So now that's black as well. You'll also note that I like tick marks on the inside, and I like tick marks on the inside of my other axis as well. Tick marks inside. And those look good. They're not too crowded. I don't need minor tick marks here. Everything looks great. Um, what else? Oh, and then my symbol is, so I always do for now coloring of my markers. The first one I put on there for marker options is always a circle. It is a circle, but I like to make it 10 points. And it's always green, and I just am going to double check that both the border of the marks of the marker and the fill of the marker is also green. And I get these big fat green circles. And our pattern for the poster is going to be, the first one is a green circle. The second data point is going to be, now let's go to marker, and there won't be any lines. No, not in our immediate future. So now I have to go to built-in to get this highlighted. And we now go to the top and we do square and we do 10 point. And then we're going to do orange, and we're going to do orange because the whole thing is orange. And now we have orange squares. And there's more information about what color and shape to do next that we'll talk about. And this, let's see, uh, you're going to end up putting hexane, heptane, octane, all the way down to N-hexadecane on here. So I'm just going to leave the legend at the bottom for now. Sometimes I like to move the legend up in here if there's space, maybe up in here if there's, whoop, don't do that. That was Control Z. Have this highlighted, have it turn into that little moving marker. Sometimes we have put it up there as well. And actually, I usually like it like that. And then spaced not too far apart. Yeah, that's be typically how I did it. Actually, I would probably move it a little more up into that corner, like so. And it knows that it's N-hexane and N-heptane. Um, and it depends on how I would do it. It'll turn out that the hexane and heptane and octane will keep getting higher. I don't know if I'd put the N-hexane on the top or the bottom, because I do like it when they're more or less in order of the way the graph appears as well. It's still the mole fraction pentane. I made my graph a little small, so let's move that. There we go. And that's a pretty good graph so far, and a pretty good head start on how to calculate the data that we need and then how to graph it.